Hi, it's Mr. Bennett here and welcome to Stage 1 Physics. We're going to go through our first video, and this is the way we're going to work this year, which will be, I will present a lot of the theory through PowerPoints and through notes done on the computer. So your job will be to obviously look at the videos, take notes, answer some questions, and then in class we will be going through those questions, plus we'll be doing prac work. Right, so that's the way we'll be working, and obviously your job is to not just memorize the theory, but is to actually understand the theory. Alright, so we'll be talking about the higher order skills. So we want you to be able to work in the higher order skills, as I'll show you with another video. Right, so if we go through what physics is all about. So in physics we want to do lots of experiments, we want to be making observations, and the word quantitative means that we want to actually measure the values. Alright, so quite often we do quantitative where we measure, or we do qualitative where we actually make observations. Alright, so obviously the historical background for physics in terms of, it was called natural philosophy. A lot of the sciences back in the Dark Ages were certainly based around religion and that sort of philosophy. So physics is probably one of the most fundamental of those particular sciences. As you know, we'll find that as you do chemistry and biology, that physics, they all sort of cross over a lot of the theory that we talk about. If you want to probably summarise it, we'll be basically looking at matter and energy and looking at natural phenomena, and that's really probably the branch of science that physics is, which is looking at new innovations, but also looking at why things work the way that they do. Some sort of questions that you might sort of ask yourself. These all could be answered using the concept of physics and looking at the areas that sort of go through that. So when looking at sunsets and sunrises, you're looking at the idea of diffraction, refraction of light, and then obviously we can simulate lightning in the classroom, and then you go down to the earthquakes and tsunamis. Well, that would be generally earth sciences, but that's certainly discussed in terms of the wave nature of physics. Right, so matter is made up of solid liquids and gases. Alright, so you probably learnt that in junior school. We divide physics into modern and classical physics. So obviously the modern physics is made great innovations over the last few years. Alright, so classical physics deals with the questions regarding motion and energy, and they're the key areas. So mechanics, heat, sound, electricity. That's pretty annoying. And then we go to the modern physics, and you start looking at the atomic physics, where you start looking at the particle nature of that, and obviously we'll be looking at the nuclear or astrophysics. All right, so those are the two areas there we're looking at. So we do have some basic units that we will be using throughout the course. Right, so obviously the quantities are measured, and we use a thing called SI units. So when you start looking at things like length, right, the symbol length is L, right, it's got a value of 1.67, and we measure that in meters is the unit, the SI unit for that. Right, so a lot of these base units that we'll be looking at, so L is length, right, and we measure that in meters. Right, that would be M for mass, right, and we measure that in kilograms. T would be for time, and we measure that in seconds. I, you might have seen before, that's for electrical current, and we measure that in amperes. And then we've got T, which is the temperature, and we measure that in degrees Kelvin. Alright, so they're our base units that we derive most things from those units. Then we have our derived units, okay, and they come from those base units. Alright, so if we look at the key ones that you might look, you've probably been used to using area. Well, area is length times breadth, and we know that is square meters. We've got our velocity, which is displacement over time. and that would be measured in meters per second. I'm probably sure that you did that in year 10. Acceleration is a change in velocity over time, so that would be meters per second over seconds, which we will write as meters to the -2. And then density is the mass divided by the volume, right, and that's measured in kilograms per meter cubed. All right, so they are just some examples of units that you might use. Right, scientific notation is really important when we're dealing with big and very large and very small numbers. Right, and we've certainly dealt with that in maths before. All right, so obviously we'll be looking at things that are like light years, massive distances. We'll be looking at things like inside the atom, where we're talking about the mass of an electron. Very small. All right, so some things that you might have seen before. You might know about RAM, 520 megabits, or you might have your hard drive, which is 80 gigabit. I think most of them now into terabytes as well. Okay, so I mean, computing, as you know, it was developed by physics type people, and advances are making with that are amazing. All right, so the sort of units that prefixes that you will need to know, and these are on your formula sheet, so you don't really have to remember them, you just need to know how to use them. So G for gigalitres, M for megalitres or mega units, K for kilo, which is 1,000, D for deci, which is 0.1 of a thing, centimetres, which is like it's 100 centimetres in a metre. All right, and then you got milli, which is 1,000th of a metre. Then you got micro, which is 1,000,000th of a metre, and then you got nano, which is what we did in year 10, and that again is 10 to the -9. So it's a billionth of a unit.